What exactly is boundary layer separation? In order to understand boundary layer separation, take a solid body. This is your boundary or the solid body above which there is a flow. And the top of it you can see that there is a streamline, and between this streamline and this boundary there is a flow. Flowing. Exit is here. Now we are taking three sections. One where the velocity is v1, and 2 velocity is v2, and 3 velocity is v3. If you look at closely, you can see that area of cross section here is the minimum. So that means v2 is greater, because you know that as fluid as the area of cross section reduces, the fluid velocity also increases. That means v2 is greater than v1, and also v2 is greater than v3. This is simply due to the continuity equation. You know that a1 v1 is equal to a2 v2 is equal to a3 v3. So when the area reduces, velocity also increases. Now what happens to the pressure here? Pressure at What is the pressure at 1, 2 and 3? You can see that P2, that is the pressure at section 2, is less than P1, because since the velocity is high here, pressure gets reduced. You already know what is the Bernoulli's equation. If you apply the Bernoulli's equation, you know the reason for that. So when the velocity increases, pressure will come down. So P2 is less than P1, and P2 is less than P3 also. Now let us look at the pressure gradient. So here dP by dx is less than 0. See, as you go in this direction, you can see that pressure gradient or the rate of change of pressure with respect to x is less than 0, because pressure reduces. So dP by dx is actually equal to P2 minus P1 by this delta x. Since P2 is less than P1, so dP by dx will also be less than 0. It will be negative. But what will be dP by dx here in this region? Between 2 and 3, dP by dx is greater than 0, because pressure at 3 is greater than pressure at 2. That's the difference. So in these two sections, you can see that here the pressure gradient is less than 0, is the pressure gradient is greater than 0. As you go in this direction, you can see that the pressure here is high, so it is moving against a high pressure. Now let us see the formation of the boundary layer. So you can see the boundary layer slowly grows from here. It grows steadily, increases up to here. So now let us see the velocity profile. You can see the velocity profile here. At the boundary, the velocity will be 0. As you move up, velocity will be increased. Finally, it will reaches the free stream velocity. Now look at the pressure force and viscous force. As you move in this direction, viscous force, because the boundary offers a viscous force that will be oppose the fluid flow. But the pressure force here, pressure at P1 is greater than pressure at 1 is greater than pressure at 2. So the pressure is actually pushing the flow in towards the right direction. Pressure force is favorable. Now let us see the velocity profile here. You can see that here the velocity boundary is 0. Slowly it increases here. Again steadily increases up to free stream velocity u infinity. But as you move from section 2 to 3, viscous force, there is a viscous force which opposes the fluid flow, and also there is a pressure force which opposes the fluid flow. Because the pressure gradient is greater than 0. As you move from 2 to 3, pressure increases. So this pressure opposes the fluid flow. Now pressure force is not favorable for the fluid flow. What happens to that? Because of that, as you move further down, velocity will gradually get reduced. You can see that at this point, the velocity at the boundary is almost zero. So that is called the point of separation. Separation. Here the velocity is actually becomes is equal to zero. Now let us see after some time what happens. The flow gets reversed because of the opposing force. Here in this portion flow gets reversed because the bottom portion viscosity effect of viscosity will be high, so it gets reversed, and this causes a lot of eddy formation. You can see that this causes a rotational flow, and this is called the boundary layer separation. This is called boundary layer separation. This is called the boundary layer separation, and this point is the point of separation. At this point du by dy is 0 is equal to 0. Is point of separation. Point of separation. So now you can see this in detail. So it clearly shows how the pressure is changing. This is a decreasing pressure towards this side, and here you can see that the pressure increases. So here you can see the boundary layer separation, and this point is called the stagnation point because the velocity gets reduced to zero here. This is a stagnate, that is called the stagnation point, and you can see the separation point here. Here the boundary layer gets detached, and this portion is called wake region. Here it is a low pressure region. This is a low pressure region. So here it will be a high pressure region. The left side here is a low pressure region. So that means that causes. So what are the various methods of preventing the separation of a boundary layer? See, because of the separation of the boundary layer, this causes a lot of drag because of the formation of the wake region and a low pressure zone. Uh, this causes a lot of drag. So how to prevent the separation of boundary layer? First method is section of slow moving fluid by section slot. You can see in the figure. So this is a section slot. So the slow moving fluid is sucked into this section slot. This is one method of separating the prevent the separation of boundary layer. And another is supplying additional energy from blower. If there is a blower here, you can supply additional energy to the fluid to prevent the slowing down. Another is providing bypass in the slotted wing. You can see that there is a slotted wing here, so the high pressure air flows over the slot. And then another method is rotating boundary in the direction of flow. Another is providing small divergence in diffuser. So you can see that if there is a diffuser, if you keep this angle low, this theta is low, that means you can reduce the separation. And another is providing gate blades in a bend. This is another method. So these are the methods used to prevent the